And ChatGPT came out for a weekend. I was in existential crisis. I was like, holy shit, like what is like, it's like man looking at a machine and like machine looking at man. It's like, what is my purpose? I was at that moment, I think I came out of that. I was like, okay, competition is solved. Like we're all going to be elevated to like spirituality or something. And I was just fully taken in by it. Like 48 hours, I was deep in it, and then immersed. Okay, this is it. This is the future.
Welcome back to Smart Speakers. This week we are going really deep into how voice AI actually works under the hood. Our guest this week is Nikhil Gupta, the co-founder and CTO of VAPI. He takes the time to walk us through the absolutely wild complexity of making voice AI sound natural at every step of the way. And that starts from detecting when people are done speaking to handling interruptions gracefully and everything in between, all up and down the stack. This is a super technical deep dive that we just absolutely loved because Nikhil is such an expert. And he also shares his company's pivot from a simple button to join meetings really quickly to now processing 44 million voice calls. Nikhil, thanks so much for coming on to Smart Speakers. Really happy to have you.
Yeah, thanks for having me, Dave and Harish. Good to see you guys.
How do you talk to people about what VAPI is?
So funny. It changes so often. Fundamentally, we do voice infrastructure. We're creating this shift to voice default interfaces. We imagine a future where we'll be talking to all of our computers, everything around us, and that's what we're excited about. That's what we are building for.
That's awesome. I know it's been quite a journey with the company, at least from what I've seen from the outside. Would love to just kind of hear the TLDR on that. Like you started doing something else and then did the pivot, like the ultimate like YC pivot, and now you guys have raised some like monster round and are like crushing it, right? So
we have had a very circuitous journey to this point, but it's been fun. We went to Waterloo, dropped out. We had COVID. We were working on projects, applied to YC, got in, applied with a different idea. We interviewed on a different idea. And when we started the batch, we had a different idea.
So you like had pre-pivoted multiple times before?
Multiple times. And
okay.
This is just a start. Like it's happened subsequently many times. We spent, a long time doing this like button to join meetings because if anyone remembers COVID times, you would get a calendar notification, you click on it, it takes you to Google Calendar, you click on the event, it takes you to Zoom web page, then you click launch Zoom, which opens Zoom, where you click OK, and then you're found in the meeting. And we hacked together a way where you get a button and you click at that in the Zoom meeting. And people love that button. That was, they paid us a bunch of money for it.
That's a lot of, we were saving a lot of time with that button back in 2020, right?
Beautiful. And that was obviously a wedge, right? Like we had way bigger ambition. If we wanted to, the way we thought about it is like, if you think about like the productivity apps that change the world, like Excel, Word, PowerPoint, email. And we were like, what's like the next one? What's the next big, thing that's going to really change how we work? And I don't think anything's quite corrected yet. Notion and but so that's what we just spent so long pivoting and iterating on, just like, what is that next itch? And then we did also add this like note taking functionality where it's like AI note taker for meetings. Like you join this button and then you get this meeting notes out of it. Again, made a bunch of money. At some point, we were default alive. Like looking ahead, we were like, we could keep scaling it, but we're not super excited about that path. It was not technically challenging. It was like I didn't really like care who I was helping. Like we were helping a lot of like super elite people like us. It was not it's exciting. And all this while like AI was just like boom, like it just started. Like the wave started. We were like, holy shit, the world's gonna change. Like why are we doing this? And pivoted, hard pivoted, and then we also moved out of Toronto to SF. Like just packed everything, just shut down everything, and just like ground zero. Let's do it. And from there was again circuitous. Like we were like exploring all kinds of things. We volunteered at like soup kitchens. Like we went to like homeless shelters. It was just like, oh, you find a burning problem, right? Find a burning problems and like solve them. All this while, Jordan made this like bot to go on walks with because we were depressed. And
this is still COVID time also, or
this is like no. This is now post chat.
Okay, got it.
2 years have passed.
Okay, cool. 2 years have passed, but we're still bummed out and walking around San Francisco by ourselves. Is that what's happening?
Basically. The TLDR of the
okay, got it. Yeah.
Classic bummed out. But then at that moment, like obviously nothing existed. It all sucked. All you had is this, like, the OpenAI like chat API, and it was terrible. to talk to it, like chain together these things. So we spent a lot of time like optimizing the latency of it, like just doing optimization generation. Like there's a lot of like tricks, and it kind of started sounding good, you know. And at the same time, this was just like he was just doing it for himself, and we were just kind of working tuning it. We saw this like, oh man, we're kind of building two companies. Like, oh, there's two projects here, like the AI therapy company, you know, and there's a voice infrastructure company. We were like, oh, we're really excited about this voice infrastructure company thing. Like maybe there's something here, and we still didn't know, obviously. And I was like, oh, this will be really cool. Like we could take on this mission to like make computers talk, and that felt really exciting. And then somehow we like Gustav connected us to like Hyperbound, which was I think one of our first customers that we built for. And I was like, yeah, we built for them. They launched it, and they were starting making money. And I was like, wait, shit, that's crazy. Like, there's like this voice thing is kind of real.
What was Hyperbound doing at the time? I'm not familiar with them.
They still do this thing. They do sales training, so
Okay,
role
cool.
play planning. Yeah, like sales people can talk to it, and
Awesome.
yeah, that was cool. And we were like, oh, maybe like just open up this platform. We launched a product hunt in March of like last year, I think, and just been like
It
single.
was only March of 24 that you guys launched your voice
Launched
platform.
officially publicly. I mean, we were building the platform with them for a while and like talking to
That is
device companies before.
so crazy.
I know, right?
It must have been a crazy ride since then, huh?
It has been a crazy ride. Could not imagine. Looking back, like there's PTSD in there a lot as well.
Yeah, for sure.
It's like keeping the system alive. It was a whole thing.
Yeah.
And now it's like different challenges. Like we can't scale the team fast enough. Just yeah, it's interesting. It's a lot of fun.
That's awesome. Thanks so much for sharing that. You had mentioned like before you moved to SF, you knew that like AI, ChatGPT didn't come out, like LLM's gonna change the world. Like what was your first kind of like aha moment?
Like when
Yeah.
ChatGPT came out, and I remember this was 3.5 term. Like oh my god, it
Yeah.
feels like I don't even know like why was so mind blowing. Like looking back, but
Yeah.
like for a weekend, I was in existential crisis. I was like, holy shit, like what is like it's like man looking at a machine and like machine looking at man. It's like
Yeah.
what is my purpose? What's the reason to try? And it was at that moment I think I came out of that. I was like, okay, competition is solved. Like we're all gonna be elevated to like spirituality or something. Anyways, like that those are there's some crazy thoughts there. But yeah, like there was that ChatGPT, like for the weekend I was just fully taken in by it, like 20 over 48 hours. I was deep in it and then immersed. Okay, this is it. This is the future.
Okay.
Yeah.
So you just like immediately had that light bulb moment.
Yeah,
And
ChatGPT, yeah, it's for sure.
that's amazing. It's funny because I feel like
How
I
about for
read
you?
this.
Like for you guys, it was like ChatGPT or something else that like made the yeah moment click.
I mean, honestly, I think there have been like plateaus of aha moments, and the most recent one is definitely just coding with Cursor and Cloud Code. It's like those existential sorts of questions that you're bringing up. I'm having them every day again.
Yeah, I feel like I was like late to the existential question party. Um, I for whatever reason was like kind of too dismissive of uh the early versions of ChatGPT, maybe because I'm a snob about writing or something. I was
Right.
like, this writing isn't very good, but like not connecting the dots, right, about improvement. And so like I definitely look back at that now and I'm like, oh shit, I like so missed this. It was so obvious that it was going to
Yeah.
get better,
Yeah.
right? But I was like
Yeah.
looking at the MVP or whatever and
Yeah.
thinking like, oh, this isn't very good, which is a dumb thing to say. Of course, it's not that good, right? It's like, but connecting back to the existential crisis mode, I remember reading this book. It's called the Master Switch about the history of communication technologies, which is really good. Recommend reading it if you haven't. And Marconi, like when the radio was invented, they were like, war is over. Like man, peace will like reign upon the earth because man can communicate with man. And you go like further back, and it's like, well, they thought the same thing with like the telegraph too. It's like every new medium and like every new thing, we're always like, okay, this is it, right? And so we've had that play out multiple times. Radio, television, the internet, now LLMs, and I think it is dangerous to think this time is different, but doesn't it just feel different though? It does kind of feel different to me.
Yeah. Yeah. We'll find out.
I
We'll
guess we'll
find
find
out.
out. I would bet on it being different.
Yeah.
Yeah. So would love to like deep dive into you had mentioned like latency being one of the first things. Like that is like one of the key challenges for voice.
One thing you mentioned in your kind of like meandering path to VAPI is that you wanted to work on something with a technical challenge. So I guess I'm just curious, like how does VAPI fit that? And if so, why? Why is it kind of like fulfilling that desire of yours.
It's funny. I think like and sometimes I look back and like my life is like remarked by like foolishness or delusions. Like where it's like yeah, like I applied to YC because I was like, how hard can it be? You know, it's like okay, let's do this thing. I'm kind of bored at big companies, and then yeah, we hopped into voice. I was like, oh, it's too easy. Like everything else, like how hard can it be? And like holy shit, there's challenges at like all layers of the stack basically. The fundamental thing is there's nothing in this world that's built for like long-term stateful workload, like long-running stateful work. Like Kubernetes is awesome and it's made like scaling CRUD apps like beautiful. And I love Kubernetes, we use it heavily, but it's not built for like again long-running stateful workloads. And then when I say that, like there's literally like even something like so advanced, like it's so what do you call like a public company like Cloudflare, they're still not built for WebSockets. Like the amount of WebSockets that they drop is just crazy.
When I hear long running stateful workflow, I think about if I'm having a 10-minute conversation with a voice AI, that's very different than making a single web request to a web worker, getting a response right back, and then you're done with that transaction. But a long
Exactly.
running stateful workflow with the voice conversation, there's back and forth. If the connection drops in the middle, that's it. Call's over. Is that what you're referring to?
That's correct. And like even if you wanted to add more additional like nuance there, it's real time. All this while, like a web request, you can have like a P99 where you take like I don't know 10 seconds, which a lot of like CRUD apps I'm sure you've seen, right? Like they're very snappy sometimes, but like there's that one tail request. Well, then like imagine like we like as an infrastructure provider have those like tail end latencies. This is unacceptable. And also like, we need to optimize like the P50s, P75s, where like we're getting audio bytes every 20 milliseconds. And like getting them as fast as possible to the worker, processing them as fast as possible. If someone starts talking, we want to shut it immediately. So like optimizing all those pieces, making sure like that's all churning at like the pace that we expect is like kind of the magic.
And I guess like one sort of like important thing that I guess I've been thinking about a lot is, like even right now, we're talking to each other. We have, some sort of like stateful communication with each other. But what we're talking about in the use case of VAPI is a human talking to a computer or a computer talking to a computer. So there has to be a long running software process somewhere that's doing what you're saying, right? Like ingesting data, responding some way. So that's kind of the setup, right? Like you have this long running software process. How are you all solving that? What are some of the details you can share?
There's like details at like low level networking stack. There's details at like the compute layer to like have persistence, like conversation state. So compute, storage, and networking, right? And there's details around like compute, like how we manage our worker fleet. And then when you hop into the actual call, there's like details around like how do we deal with each portion. And like you have telephony, like how do we do telephony, which is like its own like beast. How do we like and optimize the speed around it? For example, Twilio, everyone knows in voice, yeah, as like the at significant latency. And like we had to optimize like our telephony stack for integrating with the call centers and like other SIP providers to be like a lot lower latency. And that's like its own piece. There's the transcriber, which is a DPRAM or other Gladia assembly, whatever you use, optimizing those latencies. Like we try to develop strategies around it. Model, like we have strategies around like which model to go and where to go at this time in real time. There's strategies there, and then like as these things are being added, like how do you send to 11 Labs or any other again Cartesia, whatever voice you're using, in like the fastest way possible. So there's like layers that kind of like there's optimizations at all parts of the stack. It's very like much like thousand cuts, deaths by thousand cuts.
Maybe it'd be useful to try to sort of like step through the lifetime of audio coming in. Let's say we have the call going, so we're not necessarily focused on having the call starting up. And let's say I'm speaking, so I sent some audio over. What happens to that audio? How does it get kind of like processed, transformed, and then how do we get audio back?
We let's just say that we have gotten to the worker, right? Let's keep all the pieces like of like it traveling at speed of light to like over the internet, like that stuff.
Yeah, which is mind blowing in and of itself, right?
Yeah,
But we
exactly.
can
Yeah,
we can just gloss over that like
honestly.
incredible invention.
Yeah, and it's there in the worker now, sitting there. The first thing you'll need to do is kind of maybe clean it up. So you maybe run like some kind of background cancellation, noise cancellation model. Maybe you can also run some signal processing on it to like answer because like the audio you sent out right? So if there's like echo that you notice, you can do the cancellation there. So those two pieces will be the first thing. Is like now like let's like imagine like as I'm hearing you, right? Like there's like a lot of pieces and I'm centralizing on you, hearing you. So that's like the first piece of the pipeline.
Got it. So you're cleaning the
Isolating,
audio.
cleaning the audio, cleaning the signal to just the speaker that we're trying to talk to. The next step after that is once you've cleaned the speaker, you want to know like, are they just like, what are they doing? Like, do they end up they stop speaking? Are they interrupting? Like, there's like three cases here, right? Like if either the bot is speaking and then they might be interrupting, or are they just back channeling? It's like, got it. Like it's like those are different signals that you have to kind of process.
Right. So you're in some way, is it fair to say you're sort of like classifying intent? Like you're
Yeah,
trying to
correct,
understand, like,
correct,
is this a
exactly.
real thing that was said which has meaning? Or is it just like sounds?
Yeah, correct. Like it's like, or it's more of a semantic understanding of like, does a user now want to interrupt the bot in some
Got
ways,
it.
right?
And is this the piece that is generally referred to as voice activity detection, or is it,
But
do you think of it
this is
as something
yeah,
different?
this is the other side of it. Like now, let's say the user is speaking and bot is not talking, right? The user is speaking, so then you get into like, when is the user done speaking?
Got it.
That's a voice activity detection there, which is again same thing, like semantically knowing when a user is done speaking.
And why is that important? What happens after that
Yeah. Well, there's two pieces here, by the way. Like there's like the VAD, which is like literally the signal level, and then like the endpointing model, which is like semantic understanding
endpoint?
of the
That's right.
content.
Okay.
And all this while this is happening, right? Like the user is obviously speaking. So you might be like, not, the user is not done speaking still. But you have some confidence that like they might be done soon. There's sentences that don't have that much content at the end. Like they're very similar. Like you might get like some optimistic generation around it. Like it's like we know we have some confidence that they're going to be done speaking, and we know like they're almost like the sentence they're speaking. The last thing might not change the content of as much. So
Is
in
there a
that
term for that? Like that, I haven't actually heard folks talk about it, but the way you're describing it sounds really interesting.
optimistic generation is
Okay,
like,
cool.
yeah, you want to optimistically generate basically.
And at this point, are you still working with just the waveform, like the audio signal?
No, at this point, I think both. Yeah, waveforms, and you can assume like you've gotten like some transcribed text out of that waveform as
Okay.
well.
Okay. So you've sent it to something like DeepGram or whatever. You have some speech to text on it.
I guess I should have bifurcated. After you've cleaned the audio, you've also sent it to like a
Got it.
transcriber. We can talk about also about the speech models, but they're very similar in like terms of like that. It's
Yeah,
just like
sure.
the logic is compressed into the model layers. But yeah, like you send it to a transcriber, you've gotten a transcript, and like yeah, there's like this kind of race about like endpointing, and like you have some confidence that like actually mostly you're done, the user is done speaking, and like the last word will not change. I mean, there's some sentences that are unstable, which is like my favorite car is. That's an unstable sentence. Like there's no way to predict that. There is like more sentences that are more stable. It's like I'm gonna pick up my kids from school. Like it's like more common. And there's like sentences that are very stable. So
And is
you
is
can
this analysis being done by an LLM, or is it like
LLM. Yeah,
some, yeah,
like,
okay.
exactly. The LLM, and also you can do some like technically what do you call like as the transcripts are coming in, right? Like you can just like do a string distance against them. Also, you can string distance and like there's like I forget that there's some other algorithms there. Like you can I forget if we run a classifier like or like a BERT there, but I think we had someone explored this where like you can just like tell if the sentence is very similar. Like a
Got
transcriber
it.
outputs like a new thing, but it's like we've already sent the same thing before to LLM. We're just not going to send it. We're going to ignore it.
Right, yeah, with the latest additional characters or whatever or
Done
words, like don't change the fundamental meaning of. We don't
Yeah.
need to like resend it. That makes sense.
From this portion, you have now started the model request, let's say, right? Like we have some confidence, like we kick off like a LLM request.
So just to kind of summarize the journey to date, which is already so much, you've had some audio come in, you've cleaned the audio, presumably with some intent of like, we'll get a
Yeah.
better transcript out of it
Yeah.
if we clean the audio. And now you're running analysis on the data that's come in, basically to try to understand, should we send this to the inference layer, to the model that's actually going to be speaking, the computer speaking back to the human, or in some very real but outlandish use cases, another computer.
Mhm.
Okay.
Yeah.
And now you're sending the transcript, or, in speech to speech, I guess it would be the voice, to the inference layer.
Correct. Exactly. That's exactly right. And I guess before you send it to the inference layer, you actually
There's
need
another
to know
step.
where to. Yeah, like there's another, like you need to know where to send it.
Okay. And what do you mean
So
by where? Yeah.
where to send it is like as an example, like we have like 40 Azure deployments, and in real time, there might be a system like right now that's getting a lot of load from like I don't know, some large enterprise. That region is like bad right now, so you want to send it
Got
to
it.
like this next region. Like West US is gone. Let's go to West US one. West US two is both are gone. Go to West US three. Something like that, right? And there's obviously like model chains as well. Like a lot of prompts are like stable to get to multiple model or versions. So then you have like even more matrix multiplication kind of you can do. So what's cool about that is like we obviously like have like a real-time store of like all this information like that we update, like a real-time cache of like the latencies of all these things. So you want to quickly query this like cache to know where to send the request. That's the fastest that you know with high confidence, right? So yeah, and
So
then you send it
you're
off.
routing based on availability at this point. Like where am I most likely to get a response? Let's send it
The
You're
there.
fastest.
correct, exactly. Availability, low latency whatever you want to call it.
Got it.
So we route it to that portion, and okay, then we're waiting for streaming of tokens to come in. At this point, by the way, it's possible the user actually, like we had a false assumption that the user would stop talking or did stop talking,
Right.
and they continue talking.
Your optimism was misplaced, let's say,
Oh,
if
it's
you're
misplaced.
optimistically.
Correct. So what you want to do at the moment is just like clean up the slate, like clean up everything else next to that, right? So you'll want to abort the request. Hopefully they don't charge you for that. And if you did it in time and yada yada yada. It's the same for, I mean, if your TDS generated addition happening, same thing. You might have buffers that are being held that you know you're going to speak and now you're going to clear them. It's like in my mind, it's like similar to like how we keep things in our cache like to speak, and then if you just sometimes we just ignore them. So there might be an interruption that comes in to kind of clear that slate. But other than that, yeah, you might start getting tokens.
So now we're getting tokens back from the computer. So the LLM. And
Correct.
these are text tokens if we're, not doing speech to speech. And you're starting to get output back. Actually, one thing I want to pause on, you keep talking about streaming, right? So you're streaming tokens back from the LLM, which is not always how we invoke LLMs for every chat use case. But in this case, you're streaming, which means that as soon as the LLM has tokens available, you're getting them opportunistically.
That's correct. That's correct. And obviously there's also like prompt caching. There, like you
Right.
want to leverage providers like prompt cache, or if you're using open source, the same thing. You want to make sure these are pre-filled and the cache is hot and all that stuff. Well, I guess like there's actually one other step we possibly also missed here, which is
Fantastic.
if you want to integrate like knowledge base into your pipeline. What you might have is like user has an intent again, like a question intent this time. In that scenario, you want to actually go to your again like knowledge base provider, and you want to pick again provider that's like pretty low latency and get some relevant documents that you can feed into the context of the LLM. So like, hey LLM, here's the system prompt, here's the conversation history, here's like a relevant context to like possibly relevant context to the user query, and give me the response that you want to speak.
Got it. So just to pause on the knowledge a little bit, this might be sort of like offline data either about the user or about the task or about the provider of the
More like
ro-
about the business information. Like
Got it.
imagine like you're calling a restaurant and
Got
you
it.
want to know what are their hours like. Yeah.
Got it. And so you're fetching that so that when the LLM is creating a response, it has that potentially relevant piece of information.
Correct. So now, yeah, it might send back text tokens. It's also possible it will send out like a tool, like text tokens that are actually tool call. If a tool call happens, then there can be multiple tool calls, obviously, that the LLM decides to do. Then you want to go to the user servers, or like it might be a local tool call. Like it might be like a tool call to make SMS, right? Query, and then that'll be like integrated into within VAPI. That's by the way, that's another flow. It's multimodal. Like people don't realize how like omni-channel these things can be, right? Like the voice conversation, you're talking to them, and you're like, assistant is like, I can't get your address. Can you just like text it to me, or like, hey, I sent you a text, like just reply back with your address. and these details, like, can you send me your first name, last name, address? That can be true for sending information. They go, thanks, I booked your appointment. At the end, here's like a SMS, and people can respond and get the context back into the voice conversation.
And the way you're presenting it, sending an SMS in the voice kind of like use case is a tool that's exposed to the
Yeah,
LLM. But there
correct.
might be other tools that the user of VAPI has kind of like put into their configuration
Exactly.
of the LLM.
The developers are very creative, and I've seen some crazy,
I bet.
I'm
uh,
sure.
tools. The people will do all sorts of like controlling the UI, and like it's wild the
That's
capability
interesting.
that people find. Because I think what we're like, voice is just like the primary medium, obviously the most important and like the hardest. But again, especially when you're building a voice product, you have like you're sending images in, and like you need to find a way to inject that context also into the LLM at the right moment, and like it's fun.
Yeah,
So
it sounds really fun.
yeah, and okay, now we're at the stage where we've called the model request, right? The model request will start returning some tokens, maybe tool calls that we talked about. The tool calls might need to go through, again, like it's like either does some action within VAPI, or it might go to the users like servers, or might go to like Zapier, make other things that people use. We're waiting for a response to come back. And at this point, you want to hold the conversation still with the user, right? So there's some customization you can do around like, hey, if my API, which is this like 80 like 30-year-old service that like in written COBOL is taking like 30 seconds to respond. Here's what you should say at like second 5. Here's what you say at second 15, and like kind of programming that behavior.
Right. The way that I think about this is almost like it's the UI of the voice call. Like if there's you don't
Yeah,
get a spinning wheel anymore because you're on voice. So you have to say something to let the user know what's going on.
yeah, exactly. The way to do that in voice is just like if they talk to you, like respond back with something reasonable, like sorry it's taking a bit longer, like give me like a moment, and
Let me just check on that for you.
yeah. And you can program these as like obviously like you tell the user hold on, and then like 10 seconds later it's like sorry, still need a bit more, and then yeah, that stuff, right? You just kind of program that behavior. But now that you get the tool called results back, you want to go back to the model, be like, hey, do the same cycle again. It's like, this is the fastest model. Here's the results for it. Give me what to say. Tell me what to say. And now hopefully the output's like text tokens. Actually, no. In this scenario, when it returns like the tool call result, it might that might be something that like you need to show to the client. So you might also forward it to the voice product, and then like give that information as like a interaction moment. But like, yeah, let's come back to the voice. Like you have text tokens that are coming out. In the text tokens, as they're coming out, there's a bit of a tension where these voice models would love if you give them the entire paragraph to say. They would love if you give them the entire book to read at the once, so they
Right.
can
So
just
now
like
we're talking about like 11 labs, text to speech voice models. Yeah.
exactly the text to speech
Yeah.
models.
In my understanding of it from, what Dave and I have done is they would love to have enough context so that they can understand how to say what you're telling it to say.
Yeah, that's correct. And obviously, if you wait too long, a model like GPT-4o, it takes like 30 milliseconds between each token, right?
Okay.
So
You
if
just have that readily available. How many milliseconds? No, it's funny.
yeah,
Like you must be so in the weeds on this. You know that number off the top of your head.
in Tropic is a little bit slower. It's like 70,
Yeah.
80 milliseconds.
Yeah.
It's like I think a smaller model says faster.
This reminds me of like there's that table of like how fast like L2 cache
Yeah,
access is versus like going to RAM versus a disk actually spinning. Like this, but for different LLM providers.
yeah, basically. It's like we should make a new document, like stuff every voice engineer should know.
Yes. This is.
Yeah,
I
I would
feel
read
like
it.
I would read it. I'm sure we could get some traction with it, man. It's like everybody should know this. It's like we are all learning it the hard way, although you're learning it the hardest possible way,
Yeah,
doing it for leveraging it for thousands of developers or whatever. But yeah,
yeah,
Well, so some of what I think some of the tension you're talking about goes back to this original thing of like you're streaming tokens, right? So you're streaming tokens. You don't have the complete paragraph. There's latency involved with getting the whole thing. But at the same time, you want the speech model to say something in a stable way that doesn't, sound jarring to the user, which can often happen with these speech models.
correct.
How do you deal with that? That sounds insanely challenging.
Yeah. I mean, the reality is like we're a developer platform, so we let you configure all of these things, right? We
Right.
let you
Yeah.
configure like what's the minimum length, like what like are punctuations that you allow. Some people are okay with like when you, with them there's a dash, send it off to the 11 labs. Some people are like, no, I only want to send when there's a period and like a question mark.
So this is kind of like endpointing the text, right? Like you're saying, like when you see a dash, now you send it, and you get hopefully stable voice out of that.
Exactly, something like that, right? So there's like different ways to do it. I mean, I think we have reasonable defaults at this point, just from like data that we have seen. Every provider has a little bit different flavor of it, but like mostly it just works. And also, I think what slowly we have to request all of these providers to do is like have continuation, which is like technically like, hey, like, I'm sure I'm sending you like these like chunk by chunk, but like you already have like the cache of like what you produced before. So you can condition, the next generation on it. A lot of them support that now, like all the best providers do, which also helps. But it's definitely not as great as like if they had the entire context and like back and forth, people could look at it. The model could look at it. Yeah, you get the generation. So you started the generation of the TTS, and same thing, you can get interrupted, then you have to cancel it all. I also did that. It's kind of funny where like even using something like a period, like there's some nuance there because like doctor is not an end of sentence, like dr dot. So there's like some edge cases there, which is like you need to be careful about. So that becomes a surprising algorithm of like chunking, but again, achievable. Like there's harder problems that have been solved. What you have to do after the chunking is like you have to reformat it, because like for phone numbers you want to sort of say it in a certain way, like 415 yada yada yada. Yeah, and for addresses you want to say a certain way. For names you want to say in a certain way, and each of these like providers have different like phonetic dictionaries. So again, we being the developer platform, we expose like regex replacements for people, where they can like
That's
introduce
cool.
regex to like go from one to format to another, and we obviously have like built-in regexes as well for like all the important things like kilograms, metric tons, or like yeah, the pounds. Like LB makes no sense to like these TTS models. You have to convert that to pounds.
Yeah, we've been working on like a calorie tracking demo, and it's like, okay, you have 42 g of protein. It's like, okay, that's not a helpful thing to say.
Hopefully, like VAPI should work out of the box on it. Let me know if it doesn't. You can report a bug. I'll look at it.
Okay, awesome. Yeah.
Like yeah, we should automatically convert 42G to 42 grams
Okay.
because we have those built-in register replacements. So you do some of these, yeah, like little intricacies there to get the thing to sound good, and then now you have like hopefully audio coming in, right? But now like, you also want to match the audio as it's coming in with like the characters that were actually in that audio. The reason is like you need to know what is being spoken. What are sending the bot audio out, right? What are you actually speaking?
Right.
Like a naive way would be like you take the LLM output and they put that in the conversation history. But if
Right.
the bot gets interrupted,
Right.
then that was not the ground truth. And you
Right.
always want your conversation to be the ground truth.
You want to know what was actually spoken
Yeah,
versus
correct.
just generated.
So what you do is you pair up these audio character chunks, right? That's kind of tricky algorithm to like get those like lined up, and then you're building these chunks, right? And then like you get a green light. Like it's like we have confirmed the user is start speaking. We know what to say. Let's go. Then you will want to start sending out, like if you send obviously like too many, right, like packets out to like let's say any of these other providers, they'll buffer on their side. If if the user interrupts, then you can't clear them because most of them don't have clear functionality built in. So you need to
It's
build
stuck in some messaging queue or
somewhere.
TCP something on their
Somewhere.
side. You have
Exactly.
no idea. Yeah.
So you have to build a very tight algorithm where like you are like sending at like maybe like I think we do it at like maybe 50 milliseconds, but you can make it shorter, 20 milliseconds. I think 50 milliseconds because like if you send too little, if you send 20 milliseconds, there might be a gap somewhere. Like there might be a slight jitter. 50 milliseconds is enough where like the entire internet like works. So you send 50 milliseconds chunks and then you're holding this like buffer, but you're slicing it out at every 50 milliseconds. And if you get interrupted, you obviously clear it. By the way, if you get interrupted here, you want to be careful where you want to fade it out, right? If it's like a too like a stark cut, it's gonna be like it's gonna
It'll
Yeah, feels
sound. This
weird.
is like kind of back to the UI. Like it won't sound
yeah,
great to the user.
it'll be
Yeah.
it'll be grading exactly. So you want to
Yeah.
like a little bit of slight nudge there, and after this you've gotten the audio out, it should travel back to the user and be spoken.
So this
So
was all
it's really
just getting
simple.
audio back. How everything that we've talked about so far is basically like I think of it as like kind of like a time to first light sort of measurement of like, okay, well now we have it back, what is the ideal latency goal for getting that audio back to the user so that it sounds, sort of like natural at least?
Like, I think the number that we kind of roughly talk about is like 500 milliseconds. You could technically do 300 milliseconds as well. I think it'll be fine. The ultimate, like, the vision of this, right, is like you have like a duplex streaming speech-to-speech model. You're constantly, every 20 milliseconds, you're sending to it. Every 20 milliseconds, it's sending you something back. And there's like forever conversations. I think there's going to take some time to like really nail that architecture and like reliability of it. Yeah, 500 milliseconds is like pretty fast and like pretty smooth.
And that's like so that's 500 milliseconds for like including every single step that you've talked about, all these different heuristics, all the different branches, optimistic thing. Sometimes you try to start something and then you have to cut it out. You clear it, the user interrupts, blah blah blah. It's like that is a lot of stuff to cram into 500 milliseconds. I'm just gonna
Yeah,
put that out there.
totally. Totally. I mean, it's magical, right? Like these systems, like are crazy, like what they're capable of. Yeah, it's
So,
crazy.
and since you've been working on this, presumably you're doing a ton of calls. Is there any sort of like metric you can share about how many simultaneous calls you're doing, or maybe how many
I
calls a
think we
day?
literally today launched on Project Hunt. This is now, I don't know if I dated the recording a little bit.
No, it's fine.
The we have so far done 44 million calls on our platform. Yeah.
And so like from that range of experience, is there one part of this stack that maybe stands out as, this is the biggest pain point,
Yeah, the
or,
gnarliest thing that you've like worked on as part of this.
I really think of it as like when you think about AWS, like, is there work done? I still want more shit from AWS, you know?
Yeah.
And they'll never be done. Like once they nail like Postgres managed service, they're like, okay, we need to get it distributed. Like DSQL will be their next 10-year roadmap. It's the same for voice. It's like I'll probably believe in this future of like voice default, computing, and like humanity's default interface being voice. And like in that mode, like everything around you is an AI system. There's a lot of complexity to these AI systems beyond just the raw models. And the feature requests we get are just like breathtaking. It's like insanely complex. So the
That's awesome.
complexity is, yeah, it just grows and grows and grows. And like, it's like the new computing paradigm. Like we're moving from like a world of apps to like AI systems. And again, the voice, and we believe voice is the heart of those AI systems. So yeah, like it's just, and I don't know, it's really hard for us to answer for AWS what's like the beating heart of it. I mean, I guess EC2 maybe. For us, that would be like, yeah, like the low latency system, maybe the beating heart of it. But like, you buy AWS because like I want that managed like Redis. I want the
You want
managed.
everything. Yeah.
Yeah.
Yeah. Yeah, that's a really interesting analogy. Yeah.
Well, first, like, thanks so much for like giving
Yeah,
that
that
incredibly
was
detailed
great.
explanation. I hope folks come away with like an understanding of just like how incredible it is that like any of this works, and then be like the incredible amount of engineering that's gone into getting every step of that pipeline to be low latency, because latency matters to the user, right? It's like it's the number one thing that we've heard from folks that we've worked with. Like you talk to developers, it's just like latency, latency, latency. Like, oh, we built this thing for the customer didn't like it, so it's like a little bit too slow.
Can I also give a small like little anecdote from last week?
But yeah, please, yeah.
Yeah. It's funny, like it's like this is almost like when the question like what happens when a user types a query into the Google search bar and like what's like the
Yeah.
next steps there.
Yeah.
We talk about this like stack, right? The audio stack, but like for example, when you send that request out to 11 labs, very people know, but like we found out last week that there's 5 DNS queries that are made in Kubernetes cluster to find the 11, like where the IP of the 11 labs is.
Yeah. And that adds latency.
That has latency too.
Yeah.
Yeah.
Like the DNS resolution of it. And the reason it's like Kubernetes has 5 is because they have like local namespaces. And like that's how they
Yeah.
do DNS resolution, right? And you can reduce this number, but like it's kind of complex. And like
Yeah.
it's funny. It's like the depth of like, I mean, if you go really low, right? Like fetching the audio from those like buffers, like how can you reduce the number of kernel calls and like the user kernel switch? It's just yeah, there's a lot there. Yeah,
Sounds like a lot of fun.
Yeah.
yeah, it's interesting.
You mentioned your users made crazy feature requests and they've like kind of done like crazy things. Like what's been some of the most surprising things you've seen folks use VAPI for?
Totally. One of the more recent projects we were working closely with is like this travel agent. company, and they're making this crazy experience where like you just are talking to this thing and like it's a concierge and like it's like finding these recommendations for you, it's making these bookings for you, and the whole experience is like very futuristic. And that was the generative, I think generative UI pieces are really, really fascinating, and like integrating that like very smoothly with like voice as an experience. Because
It's a
sometimes
whole
you
new
want
UI paradigm, right? It's like there's all this stuff that we're all learning as we go, right? Like we've like unfortunately like trained consumers that like voice systems like are shitty, for the last like 30 years, right? And now we're gonna like hopefully reach people will learn again that like, oh man, like voice, you can actually do so much more. It's like
it's going to
actually
get
way
better than
better.
humans very quickly, right? And it's
Yeah,
just that's
exactly.
the improvement curve, and that's really exciting for sure.
Yeah. Y'all just raised a big round. Like and you've made some like big product announcements, right? So I'm probably missing some, but the ones that hit my radar screen are like you've got your own voice models now. So not just third party voice providers, but your own. I would love to hear about that. And I also saw, I think that you have like a text interface to the kind of like the VAPI brain.
Yep.
VAPI brain, excuse me. I'll edit out the VAPI part so we don't have to hear it.
That's good. That's good.
Yeah, so we'd love to hear about that and anything else you're excited about that's coming down the pipe.
That's exactly right. I think like there is a lot for us to invest like in everywhere. The biggest challenge we have is like we can't find people fast enough. So if anyone's hearing and they're like excited about building the future of voice, find me. So like there is a lot. Yeah, we obviously raised around like 4 or 5 months ago. It feels like forever, honestly.
Yeah.
We have doubled. I think actually no, like we have 2.5x like since then, in terms of revenue, and like the team size is I think like 3x now. So we were 4 engineers back then, and
4
now
engineers.
we're 16, and we will be 30 in like 4 months. So we double again in 4 months, and yeah, that's the biggest challenge is like finding great people. And what's coming down the pipe is just everything. All cylinders, full
Love that
cylinders everywhere.
answer.
Like like we invest a lot in like again like the core infrastructure, like improving those like pieces, model integrations, like get those integrations out, making the agent experience really easy. That's the hardest piece. If you ask me, is like that piece right now. It's like how do you make the agent experience really smooth, like the OODA loops, right? Like the developer loop, if you will.
Yeah.
Creating this agent, like it takes like a long time to like really get it production ready. So investing a lot in that. We obviously again have to support a lot of these enterprises that are like trying to scale up, build these amazing products. So just full cylinders.
Staying busy.
Staying busy. Yeah.
That's awesome. Well, to wrap from our side, we usually ask folks, if they have anything that they've been like reading or listening to that you would recommend. It sounds like you may be working too much to have anything to recommend, but if there is something.
I read a lot of like, I don't, do you know Ben Thompson, Stratechery?
Yeah, for sure.
Yeah. I read him pretty heavily. I love that. I recommend that.
It's
really
just got great insight. And he's just had an amazing track record also of just like really nailing it for years and years. Yeah.
Yeah. It's beautiful. Like the way he phrases it, things, and like, yeah.
That's your rec.
Fantastic. Great rec.
Yeah. Awesome. Well, Nikhil, thanks so much for coming on the show. We're going to link to, VAPI and all I'm sure everybody that's listening already knows about VAPI, but like, we'll link to everything. And of course, I'll echo, if anyone out there is interested in working at VAPI, you should reach out to Nikhil. It's been a great conversation. Really appreciate you diving so deep with us. And we'll chat more soon. Thank you. Thanks again for listening to Smart Speakers. We've got a couple more episodes this season before we take a short break. So if there's anyone you want to hear from, now is the time to let us know. Ping us at founders@unison.fm. See you next time. Thanks for listening.